guys, I am Kasia Rutkowska and I will present you today the topic of document AI. I will shortly summarize how multimodal models which are used in this area work. So agenda is as follows. First, I will introduce you to the topic of document AI and multimodal models in general. I will focus on the example architectures of layout LM v3 and LILT. At the end, I will summarize what we have discussed. Why do we even need document AI? This topic arose from the need to structure large volumes of documents, such as invoices, receipts, emails, etc. And the need to extract some information from those documents. Also, it is applied, for example, to classify documents into predefined categories. On the example of invoices, we can imagine that some company could want to obtain a structured format for all of the invoices that they process so that the output could look like the one on the image. We might imagine to have a date, sender, recipient, amount paid for particular services, and a total amount. And what is difficult about this process? If we dive deeper, how we could find what is the total amount paid for this invoice, we see that the value is here in the bottom right corner, and it's near to the keyword total, but it's also near to some other values. For human, it's quite easy to read such documents, but to automate this process it's not trivial. First, we need to extract text from the document, so we use OCR. And output of such tools is sometimes better, sometimes worse. In case of complex layouts, such as tables, etc., it's not obvious how to read this document. So we can see that the table is not parsed perfectly. The value of the total amount is no longer near the total keyword. So it's not that easy to extract it via text processing tools. So basically, this is a good example why we need something more than text processing. To handle such complex layouts, we have a field of document AI called layout analysis, and it focuses on visual perception of documents. It tries to structure a page of a document into big chunks of information which are classified into classes. So on this image, we can see a table, a figure, text columns, for example, a header in a text. And these objects help to process the document better. For example, if we know that we want some text fields extracted, we can omit the figures and tables, and we can easier preserve the reading order of the document. Layout analysis is actually included in the good OCR tools, so they return not only the text but also figures, tables, etc. So now that we know a bit more what are the applications of document AI, we can dive deeper how it is built. It emerged from the need to process documents which are not only text but also images and structured information. So it tries to merge two fields of NLP and computer vision. Document AI usually incorporates many tools such as OCR, layout analysis, language detection, to solve tasks such as document classification, information extraction, etc. To process documents with such a complex structure, we need something more than just computer vision or just NLP. So for this reason, multimodal models were developed. They can incorporate at least two or three of modalities. Those modalities are the ways in which we can look at a document. If we just look at the image, it's the first case on this chart. We use computer vision. Then, if we use OCR and obtain bounding boxes and locations of all of the tokens on the image, we use the spatial or layout modality. And then, if we process the text, it's the last of those three modalities. Multimodal models, as I mentioned, can incorporate two or three of those modalities: text, layout, and image. Bert and Roberta, which we all know well and heard of many times, they're a pure text model. Then, if we think of image processing, we think of models such as ResNet, UNet. They can be combined, and example of such model is Visual BERT. And then we have models which also incorporate layout information. Example of such model is LILT. In the middle, we have layout LM and tilt models, which use all of those. As everyone probably heard, GPT-4, the newest version of GPT, is announced to be multimodal in the future. It's not released yet, so we don't know the details. But we can see that this area of research is developing fast. The models involved, LILT and layout LM, are going to be the focus of this talk because they are open source, and I have some, and I just used them in the previous projects. So layout LM v3. If we think of the high-level concept, how it was built, we start with a document and we want to obtain a multimodal representation. So to obtain text, we OCR the document. From the OCR, we get text which is then embedded by Roberta, and bounding boxes, which are a representation of the layout modality. From the image, we build the image embedding, and a model learns this joint representation. If we look at the history of this model, it started in 2020 with the first version of the model. It only used two modalities in the pre-trained base, so text and layout. For the for the image modality, they used a computer vision model, and these embeddings were only used during training the downstream task. So the base of the model was pre-trained on the large corpus of documents, but the image modality wasn't pre-trained in this version. The second version also included the image modality in the base, and they used ResNet backbone to obtain those embeddings, which were also pre-trained on a large corpus. The last version said that using a computer vision model to obtain image embeddings is problematic and is a bottleneck. So they decided to flatten the embedding, to not use CNN-based encoders, and obtained better results. They also unified pre-training objectives of the whole model, so that the architecture is a bit simplified, and text versus image modalities are pre-trained in a very similar fashion. Here we have a more detailed architecture of layout LMv3. We can see that a document is analyzed in two ways. First, it's OCR'd and passed to the text encoder, but also the image is split into patches and flattened to obtain those linear embeddings of the image. So what is coming into the model are word embeddings, image embedding, and positional embeddings coming from OCR. All of those information is processed by the multimodal transformer, which is pre-trained on a corpus of documents with three learning objectives: masked language modeling, masked image modeling, and word patch alignment. This third objective aims to align the words which are passed to the model with the image chunks. Comparison from the paper, when this model is compared to other models released before, the authors state that it differs in two ways from other models. First object of differences is the image embedding. As I mentioned, they simplified processing of the images to get rid of CNN-based models and just used linear embedding of the images. The pre-training objective on the images is masked patch token classification. Okay, here we have some added features on the image by Tomek. But Layout LM is a powerful model. Here we have some supported tasks of this model available in. This model is available in Hugging Face, and we can use it to solve different kinds of tasks. For example, by using sequence classification, we can use the model to classify documents into different categories. By using token classification or question answering, we could extract some information from the documents. But this model has also some drawbacks. It's not possible to abstract information from the documents. So, for example, if we want to summarize a document or make an abstract of information which are in the document, it's not possible. But there are alternatives such as Tilt or maybe GPT-4 in the future. They are not open source. We could either try to reproduce them or pay to use them. Okay, another model which I want to mention is LILT. What's interesting about this model is that it's language agnostic. So a difference to LayoutLM is that we don't have Roberta here, but we can choose from many text encoders, even with different language. We also don't have image embedding here, but it's a it's a different difference. On the results, we will see if it has high impact or not. The architecture of LILT is divided into two flows. Flow on the left is the text flow, which can be almost any text encoder, Roberta or any other, and the layout flow. Those two flows are later concatenated to result with joint representation. Okay, here we have a comparison of the models. It is taken from LayoutLM v3 paper. In the table, we have two main rows. The one on the top are smaller models, and on the bottom, there are larger versions of the models. On the top of each row, we have the pure text models. So in the modality column, they have only T for text modality. And the results are reported on 4 data sets, which mainly focus on documents such as receipts, invoices. RVL is legal documents. It's classification, so the metric is accuracy there. And what's interesting is that pure text models are quite strong baseline, but they can't go as far as multimodal models. So, for example, on FunSD dataset, we have a difference around 15% between the text model and LayoutLM v3. On other datasets, we observe a smaller difference. So it's also interesting. It for sure depends on the dataset, on the task, if it requires more of the complexity of the model. We can also see a comparison of the LayoutLM v2 and LILT versus LayoutLM v3. Of course, LayoutLM v3 is the best, or almost the best, because it's from the paper. But we can see that LILT, which is a smaller model, doesn't have that big of a difference here. Okay, to summarize, LayoutLM v3 is a powerful model for document AI tasks. It consists of 3 modalities: text, image, and layout. Its code and model is publicly available in the internet, but it's released under non-commercial license. On the other hand, LILT is a language agnostic model. It only consists of text plus layout modality, but it's released under commercial use license. So it's an interesting choice. From my experience on the data sets which I used, the performance was quite similar. And what else? I think that these are interesting and powerful models, but it's always worth to start a baseline with pure text model. Okay, here we have some resources. Those models are released in the Hugging Face library. And I encourage you to read more in the papers and check out the TILT model, which is an encoder-decoder model, which has the ability to abstract information from the documents. So that's it from me. Thank you for listening.